Dear students, under the topic linear asymptotes, here we have the first problem. In our previous video, we learnt the definition of asymptotes, types of asymptotes, and the rules to solve an asymptote and the cases under them. Now in this video, we will consider an cubic equation and solve it and find the asymptotes of this given cubic equation. Now here the given cubic equation is 2x cube minus x squared y minus 2xy squared plus y cube plus 2x squared plus xy negative y squared plus x plus y plus 1 equals 0. Now, in order to find the asymptotes for this given equation, the first step is we have to check for the highest degree of this given cubic equation. That is, under the rules, step 1 is we have to check what is the highest degree. But we know that we are solving a cubic equation, and therefore the highest degree of this equation will be 3. And so the number of asymptotes for this equation will be equal to 3. So first step is we have to write the number of asymptotes for this given equation, which will be equal to 3. So what are the 3 asymptotes for the given equation? We have to take them as I have already given here in our previous video. I explained it. So we have to take this as the 3 equations of the given asymptotes. Three asymptotes of the given equation. So the first equation will be y is equal to m1x plus c1. The second equation of the asymptote will be y equal to m2x plus c2. And the third equation will be y equal to m3x plus c3. So we have taken the 3 asymptotes. Now in this we have to find the value of m1 and the value of c1, similarly m2 and c2 and m3 and the corresponding c3. So how we will be finding it? The second step is we have to find the values of m1, m2 and m3, for which we have to find phi 3 of m and equate it to 0. Now how we will find phi 3 of m? Phi 3 of m is obtained by putting x equal to 1 and y equal to m in all the terms of degree 3. Because the highest degree is 3. In the highest degree terms, we have to replace x equal to 1 and y equal to m and find the value of phi 3 of m. So first of all, we shall write all the terms with degree 3. So now in this given cubic equation, what are the terms with degree 3? Here we have 2x cube. So this comes under third degree term. Here we have x square y. The degree of x is 2 and the degree of y is 1. So we have to add the degrees of the variables and consider that to be the degree of that particular term. Now here the degree of x is 2 and the degree of y is 1, because y is just given, so which means y to the power 1. So what is the degree altogether? It is 3. So this is also a third degree term. In a similar way, here we have minus 2xy square. Now the degree of x is 1 and the degree of y is 2. So adding those two powers we get 3. And so this also comes under the third degree term. And here we have y cube, which is a third degree term. And rest of the terms are not of degree 3. And so therefore, the highest degree 3 of the terms of highest degree is, these are the terms. That is 2x cube minus x squared y minus 2xy square plus y cube. So let us take that and write now. So terms of degree 3, that is the highest degree. So what are the terms? We will take and write it as it is. So 2x cube minus x squared y minus 2xy square plus y cube. Now after taking and writing, in these terms we have to put x is equal to 1 and y is equal to m to obtain phi 3 of m. Now what is this phi 3 of m? Phi 3 of m is, in this third degree terms, we have to replace x equal to 1 and y equal to m. So now phi 3 of m will be equal to, now here we have x. So we should put x is equal to what? 1. So we will be getting 1 cube. So 2 into 1. So it will be 2. Minus x square y. X is 1, so 1 square multiplied with y. Y is what? M. So it will be 1 into m, so it will be only m. Minus 2 x square, we have only x here, so x is 1. And then y is m, so it will be m square. So 1 into m square, so it will be only m square. Plus y cube. Y is what? M, so m cube. So this is phi 3 of m. This is how we have to obtain phi 3 of m. After obtaining phi 3 of m, we should equate this phi 3 of m to be equal to 0 in order to find the value of m. So we have to put phi 3 of m to be equal to 0. So we will rewrite this according to the powers of the term. So this will be m cube, okay, and then minus 2m square minus m plus 2 is equal to 0. So I have written in the order of the power and it is equal to 0. Now we have to find the roots of this equation. So how we will be finding the roots of this equation? In order to find the roots of this third degree equation, first we have to use trial and error method and find one of the root. And we have to simplify the given equation by using synthetic division and obtain an quadratic equation, and then solve the quadratic equation and find the other two roots. So first step is what? We have to obtain one of the root by trial and error method. We have to start with 1. We have to check whether 1 is a root of this equation. So what we should do, we should put m is equal to 1 in this equation and we have to check whether we are getting it as 0. So if you put m is equal to 1, what are you getting? 1 cube is 1 minus 1 square is 1. So you will be having 2 minus m is 1 plus 2. And that is equal to what? Negative 2 and plus 2 will get cancelled. Plus 1 and minus 1 gets cancelled, and of course you are getting 0. So m equal to 1 is a root. So is a root of this cubic equation. So m equal to 1 is a root. Now we have to obtain the rest of the roots by using synthetic division. So how to do that? So for synthetic division, we have to take and write the coefficients of this cubic equation. So what is the coefficient of m cube? It is 1. So write that 1 over here. What is the coefficient of m square? It is negative 2. So write negative 2 here. What is the coefficient of m? It is negative 1. And then the constant term, which is 2. So we have to write all these terms. Now we have found that m equal to 1 is a root. So now we have to divide this equation with that root by using this synthetic division. So first of all, this 1 comes as it is. So we will be having 1 here. Now multiply this 1 and this 1. So 1 multiplied with 1 is 1 only. So write that over here. Now minus 2 plus 1. So if you subtract, that is if you do minus 2 plus 1, what will you get? You will get minus 1 over here. Now multiply this negative 1 with this 1. So 1 multiplied with minus 1 is minus 1. So minus 1 minus 1 is minus 2, because we have to add them and we have to write the negative sign. So minus 2 into 1 is minus 2. And of course we are getting the remainder as 0. So if this is a root, then it should exactly divide this equation so that you get the remainder as 0. So after getting the remainder as 0, using these terms, we have to write the quadratic equation. Now this will become the constant term, this will become the coefficient of x term, and this will become the coefficient of x squared term. So coefficient of x term, and this is coefficient of x squared term, and this last term will be the constant term. So how will it be? So coefficient of x square is 1. So 1 into x square. Coefficient of x is negative 1. So negative 1 into x. And then the constant term is minus 2. And so minus 2 is equal to 0. So this is the quadratic equation which we obtain after using m equal to 1 as a root and dividing the given cubic equation. That is the cubic equation which we obtained in our previous step. Now we have to solve this quadratic equation. That is, we have to factorize this and we have to find the other two roots. I have written x over here. We have to write m actually because we are using m here. So in general, in algebraic theory, I just showed you how to write. So replace that x as m. So you will be having m squared minus m minus 2 equal to 0. Now we shall solve this quadratic equation. Now in order to factorize this quadratic equation, I am going to use the Hill method. You can also use the formula method, which is minus b plus or minus square root of b squared minus 4ac divided by 2a. You can use either that method or you can use the Hill method, which I am going to use now. Now here I should check for the constant term, which is minus 2. I have to multiply this with the coefficient of m square, which is 1. So 1 multiplied with minus 2 will be minus 2. Now I need to factorize this in such a way that the sum of the two numbers that I do should give me the middle term. Now here it is minus 2. So I am writing 2 1 times is minus 2. But I need a negative sign here. And if you see, in the middle term we are having negative m. So when you add these two, you should get negative 1. So if you write minus 2 here and plus 1 here, now if you check, minus 2 plus 1 is minus 1 and minus 2 multiplied with 1 is minus 2. So we are getting these are the factors. So now so we can write this as directly also we can write m minus 2 multiplied with m plus 1 is equal to 0. So from this the value of m is equal to 2 and the value of another value of m is equal to minus 1. Already we had the value of m to be equal to 1, which we solved previously. So the three values of m is 1, minus 1 and 2. So therefore we will take m1 to be equal to 1, m2 to be equal to minus 1 and m3 to be equal to 2. So now we have found all the three roots, m1, m2, m3. The next step is we have to find the value of c. So how we will find the value of c? We should check whether all the three values of m are distinct or equal. So if we see here, all the three values are distinct. They are not same. They are not equal. So therefore, the formula to find the value of c will be, so we will be having three values c1, c2, c3, and the formula to find c1 will be negative phi 2 of m1 divided by phi 3 dash of m1. So let me write that here. C1 is equal to negative phi 2 of m1 divided by phi 3 dash of m1. So in general, first of all we should find phi 3 dash of m and phi 2 of m. So we know that phi 3 of m already we wrote. What is that? We wrote previously here. Phi 3 of m is this. So 2 minus m minus 2m square plus m cube. So let me take and write that. So phi 3 of m is 2 minus m minus 2m square plus m cube. We need phi 3 dash. So we have to find phi 3 dash of m. That is, we have to differentiate this with respect to m. The differentiation of 2 is 0 minus the differentiation of m is 1 and the differentiation of m square is 2m and it gets multiplied with this minus 2 and so we get minus 2 times is 4, so 4m plus the differentiation of m cube is 3m square. So this is phi 3 dash of m. Next we have to write phi 2 of m. Now what is this phi 2 of m? It is, we have to write the terms with degree 2 first. Find the terms with degree 2 in the given cubic equation. So what are the terms with degree 2? Here we have the power of x to be 2. So this is degree 2. Now here we have x to the power 1, y to the power 1. If you add the powers of the variables, you get it as 2. So therefore this is also a second degree term. And then here we have y square. So it's a second degree term. The rest of the terms are not of degree 2. So the second degree terms are this. So these are the terms of second degree. So 2x square plus xy minus y square. Now let me take and write that. So what are the second degree terms? 2x square plus xy minus y square. Now in this, let me put x is equal to 1 and y is equal to m in order to get phi 2 of m. So therefore phi 2 of m will be equal to, if you put x equal to 1, you get 2 and y equal to m. So 2, you will be having only m and then minus m y square, so minus m square. So this is phi 3 dash of m and this is phi 2 of m. So let me take and substitute. So the value of c1 will be equal to negative, what is phi 2 of m? It is 2, so let me put a bracket, 2 plus m minus m square divided by phi 3 dash of m is this, so which is minus 1 minus 4m plus 3m square. Now in this, to find c1, I should put m to be equal to m1. And what is the value of m1? I have written here, m1 is 1. So we have to put m1 to be 1. So therefore the value of c1 will be equal to, so negative of this negative sign you should not forget. So negative of 2 plus m is what? 1. So 2 plus 1 minus 1 divided by, because 1 square is 1 only, divided by minus 1, and then when you substitute m equal to 1 here, you get minus 4 plus 3 into 1, so 3. And so that will be equal to minus of, this plus 1 and minus 1 will get cancelled and you will have 2 in the numerator, divided by, what is minus 1 minus 4? It is minus 5. Minus 5 plus 3 you should do. So you will be getting minus 2. And now these two terms gets cancelled and minus into minus is plus. So it will be only 1. So the value of C1 is equal to 1. So therefore the value of M1 equal to 1 gives us the value of C1 to be equal to 1. Now secondly, we have to find C2, for which we should use M to be equal to M2, which is equal to, what is the value of M2? M2 is negative 1. Now in this we have to use m to be equal to negative 1. So if you put m equal to minus 1, we get minus of 2 plus, so negative 1, so minus 1. Minus 1 square will become plus, so minus 1 divided by minus 1, and here when you substitute minus 1 here, it becomes plus 4, and minus 1 here, it is 3. Now in the numerator, 2 minus 1 will become 0, and therefore the value of C2 is equal to 0. So when M2 is equal to negative 1, the value of C2 is equal to 0. In a similar way, we have to find the value of C3, for which we have to use M to be equal to M3. And what is the value of M3? It is 2. So 2, and substitute the same in this. So what you will be getting? You will be getting the value of C3 to be equal to, now if you substitute m equal to 2 over here, you will be having minus of 2 plus 2 minus 2 square is 4 divided by minus 1. 4 2 times is 8, so minus 8 plus 2 2s are 4, 4 3s are 12, so 12. But anyway, in the numerator, we see that 4 minus 4 becomes 0, and so C3 also becomes 0. So when M3 is equal to 2, C3 is equal to 0. Now using these values and substituting these values in our equation 1, 2 and 3, we will get all the three asymptotes. Now first asymptote will be y equal to m1x plus c1. So what you will get, you will have y equal to, what is m1? The value of m1 is 1, and what is the corresponding value of c1? It is also 1. So when you substitute that, you will be having m1x, so 1x plus 1. So y equal to x plus 1. But from this we will get, bringing these two terms to the left hand side, we will have y minus x minus 1 is equal to 0, which is the equation of the first asymptote. Now, using the second equation, we will have y to be equal to, what is m2? m2 is equal to minus 1, and corresponding c2 is 0. So when we substitute that, here you will have y equal to minus x, and c2 is what? 0. So anyway, it is 0, so we need not write. So from that we get, taking this minus x to the left, we get y plus x to be equal to 0. So this is the second equation of the asymptote. And the third equation is obtained from this, y equal to, so from this you will have y equal to m3x. What is m3? m3 is 2, and the corresponding value of c3 is anyway 0. So m3 is 2, and so when you substitute the 2 over here, you get 2x, and anyway this is 0, so we need not write. So it becomes y, taking this to the left, y minus 2x to be equal to 0. So therefore the three equations of the asymptotes are y minus x minus 1 equals 0, y plus x equals 0, and y minus 2x is equal to 0. So therefore finally I have taken and written the answer here. Therefore the equations of the asymptotes of the given cubic is this. So hope you have understood this problem of solving and finding the asymptotes of a cubic equation. In our next video, we will learn when the roots of m are equal, how to solve for the asymptotes. Now here in this equation, we found that the roots were distinct. The three values of m were distinct. So we used one unique formula to find c, and we solved the problem. Now when the three values are not distinct, because if suppose one of the two values are equal, then how to solve, we will learn in our next video. So kindly follow the next video for further problems on asymptotes. Thank you.